Greetings, everyone. Welcome to our exclusive Global Leading Voices webinar campaign. We are delighted to have you join us here today. Please be informed that if you have any questions during the presentation, you may type them into the question box in your control panel. The presenter will answer your questions at the end of the presentation accordingly. Now, without further ado, we will turn the time over to our presenter, who will begin shortly.
Hello to all that are attending. Thank you for taking the time out to do this. There was a change of plan, as Ardian emailed you earlier today. Unfortunately, the original speaker has been taken ill. And I'm Chris Ward, and I've presented for PCB on a number of different occasions, mainly on ISO 45001. But today I'm going to talk from experience with my background as a regulator for the UK's Health and Safety Executive. I'm just going to give you an insight into accident investigation using 3 case studies to try and draw out the learning points. And as you'll see with the title, it's how small errors lead to tragic consequences. So I spent almost 40 years as an accident investigator and regulator with the Health and Safety Executive across a wide range of manufacturing and service sectors. And in the latter part of my career, I helped revise HSG 65, which is a safety management guidance, which is used worldwide. And since I retired from Health and Safety Executive, I've investigated fatal accidents for organizations around the globe. And that has been a significant learning point for me as well. Okay, I think that's enough about me. And where are we going to go with the small errors leading to tragic consequences? Now, as safety professionals, we'll all be saying we learn from incidents. And how do we do that? And what benefit it gains us is sometimes difficult to put into practice. So this is why I thought we'll look at some of these case studies and see what lessons we can draw. In these case studies, you will see that the original initiating error is very, very minor, well, but leads to tragic consequences. And they're technical errors that I'm going to talk about, and then we'll overlay them with organizational issues as we go through. One of the key things that I've learned in accident investigation is, it goes without saying, the importance of gathering facts. But unless you've done a lot of these accident investigations, you get drawn away from the evidence by people's opinions, by just the pressure of the circumstances. People have been injured, there are next of kin to deal with. Production needs to start up. There's people milling around you, and it's easy not to concentrate on what you need to do. And the first thing you need to do as the accident investigator is gather the facts. Photograph them, make a note of them, measure them, take them into possession, do everything you can to make sure that you know what happened and what is happening and what you see around you at the time. And of course, it goes without saying, you've got to visit the accident scene. Having done that, there are many different ways of going through a further investigation process about gathering information and statements and trying to understand why the accident happened. Why did this happen? Why was the scaffold not inspected? Why did the scaffold not have a guardrail on it? Why did the person who should have put that guardrail on didn't do it? Why was the person not trained? Why didn't the person attend the training course? And so on and so forth. There are more sophisticated techniques, but don't get distracted with those in the initial part of investigation. the techniques will help you with analysis, and the difficult part then becomes the actionable plan. I'll do some analysis today, but the biggest challenge to it all is trying to put those lessons learned into a practical methodology of preventing further accidents. And I'll say at this stage, and I'll probably repeat it, that if you've had to investigate an accident, you'll probably find that those circumstances will never be repeated. This is the peculiar and unique nature of accidents. The circumstances will never fall in place in the same way ever again. There will be similar things, but everything will never be exactly the same. So just a word of warning, if you try to prevent the accident happening again, you'll probably be caught out, because a similar accident will happen in slightly different circumstances. And here is almost the lesson and the message of that. You've got benefits of hindsight, and if you do a proper investigation, you'll see how it all comes together. But it doesn't necessarily mean that you can prevent the next one, particularly if you've not done a good analysis, and that you can't get the human beings to help you implement the action plan. At the end of the presentation, I'll come on to some thoughts about what's going to happen in the future with health and safety. There's a difficulty in getting safe workplaces and safe workers, and some organizations and some cultures and some countries are finding that they're plateauing in terms of reducing accidents. So a number of people have come up with this turn of phrase, safety differently. I'll touch on that at the end. I mentioned the sort of typical accident investigation process. There are sophisticated ones. I'm going to use the one that's developed and on the Health and Safety Executive's website. There's detailed information. The link will be on a slide near the end, and you can read the guidance on accident investigation. And I'm just giving you a few snippets of it here. But essentially, the investigation process is in 4 parts. Part 1, the overview. That's where somebody would report the accident and say XYZ fell off a scaffold and was badly injured, a broken leg, gone to hospital. That's the brief details. Part 2 is if you are a safety professional, of those attending the webinar, it could well fall to you to do the initial assessment. Part 3, investigation information gathering. That again will probably be yourself, but use others to perhaps to bring information and evidence to you. But don't forget what I'm trying to emphasize today, and that is make sure you get the facts, and as soon after the accident as is humanly possible. And then you move on to, in that investigation information gathering, analysis and further action. And then come up with this actionable plan. That is the difficulty. And let's hope that we can trigger some ideas in you after we've gone through these case studies to think about how you would develop an action plan for your organization. I want to briefly touch on something that many practitioners know about and understand, and that's the accident triangle or pyramid, where you have accidents at the top of the pyramid. Somewhere in the middle there will be reactive work associated with the accidents and their reactive measures, and then we have proactive actions, and I'll go on the next slide to explain a little what I mean by that. Our next slide shows you an extended accident pyramid, where you'll see in the colors 1, 2, 3, 4, or if you're colorblind, the 4 slices at the top of the pyramid, which shows as fatality, severe injury, minor injury, and unsafe acts and conditions. And that from here up is a typical accident pyramid. You see where the point is working. What I've underlaid on this is, or are, the proactive actions that as mature safety practitioners and more mature organizations should be taking, all these proactive actions. You can use different names for them, and it could be training, it could be inspections, checks, audits, all those go down there, proactive actions. And that gives you layers of protection to try and prevent these accidents and incidents. But what I want to do to illustrate something now to you is to show you that there's two, how should we say, mathematical paradigms going on here. One is that if you're just concentrating on the colors here, if you try to avoid that fatality, and I've already said each fatal is probably quite unique, very difficult just to try and stop that one fatal by looking up here. What you do is generally to try to reduce the base of the pyramid by reducing these unsafe acts and conditions. And what it will do is purely by cutting out the lower segment, reducing that layer mathematically, because these are in a direct proportion to each other. If you reduce the width of that, and I'll reduce the width of that and keep the proportion the same, you'll see I'll also reduce my minor injuries. I'll also reduce the severe injuries, and if I'm fortunate, I'll reduce a fatal accident. So that's why we try and reduce unsafe acts and conditions. That doesn't work for proactive actions. What is required for proactive actions is you want more and more of these actions, more accountability, more safety recognition, rewards and recognition for people, greater communication, improved supervisor performance. And what happens there with this part of the pyramid is, if you consider this is just a fixed volume, you stretch the base of this as much as you can by more and more of these things. And what happens is it draws the top of that pyramid down from fatal and from severe to minor to unsafe acts, if you follow me. So you cut the top of the pyramid off by increasing these actions down here. So an interesting way of looking. Let me dive now into some of these case studies. For those of you based in the UK, you probably recognize this as a massive explosion that occurred a number of years ago. But this is an oil storage and petroleum storage depot in the UK, in England, called Buncefield, that was a significant event and explosion. The biggest peacetime explosion in the UK since the Second World War. It was a big bang, and the smoke pall actually went over through to Europe as well, caused by over 250,000 litres of petrol igniting early one morning. I think the cost was something like £5 billion pounds sterling, and $7 or $8 or $9 million in euros. The point I want to see about this is that the reason that this explosion occurred is that fuel was being pumped into a storage tank from another part of the UK. This is Buncefield, based here. The fuel was coming down pipelines, so it's pumped remotely and went into the storage vessel. A control room, it was a big storage tank farm. In the control room, they had indicators showing high level alarms. The alarm didn't work for fairly simple reasons, really. And because the alarm didn't work, the fuel was pumped continuously into that tank until it overflowed. Here, and it fell into the bund, and there was so much of it, it just continued to overflow and spread for hundreds of meters around this tank farm. And when eventually the source of ignition was found, as inevitably there will be, was of this massive explosion. So, all caused by a simple thing. This is the high-level switch. This is one of them. There were a couple of them, but essentially the switches didn't work through a system of bad design. Operators didn't know the importance of making sure a padlock was in place. Without the padlock, this switch lever, which is used for testing it, would fall to danger, so that the whole system itself didn't work. A simple thing, very simple thing, and for in the order of the world, quite an inexpensive piece of equipment, leading to tragic consequences in terms of financial loss, but nobody was killed. Similarly here, this is an accident I investigated. You'll see a building with a sheeted scaffold. That's how it should look. But one night there was a high wind, and the wind blew that sheeted scaffold so that it expanded like a balloon and fell off the building. And again, fortunately, nobody was injured. It happened at midnight, and there was nobody in the vicinity. Some piece of the scaffolding fell down there. So sheeted scaffold, why did that fall? Why was that blown off? The design met British standards and normal standards, but the installation by the contractors did not meet the specification. What they didn't do, I'll come on to in a minute, but here in terms of the massiveness of the problem, the biggest problem for safety now is that it's hung up there, and it took the region of 5 days to dismantle that safely. So the incident itself caused potentially a bigger safety risk than the moment when it came off the building. So what was the simple thing that allowed that scaffold to be blown off? The scaffold was tied into the building with these bolts, which are, as many people will recognize, drilled into the substrate of the building, the concrete face. A hole is drilled. This part is then pushed into the hole, and then the ring is screwed into it, and that part then expands to hold it into the scaffold. The contractors did not put sufficient ring bolts in. They were probably only about 30% of those that should have been put in. And here is the importance of gathering facts. How could I prove that there weren't enough ring bolts? Well, I could count the number of holes in the face and the facade, but I didn't have any methodology of getting up there safely, nor what I wanted to. So when all this was dismantled and fell to the floor, we sifted through all the scaffolding to find those ring bolts. And we found that there were only 30% of those put in. And those that were put in were not put in effectively. The person who putting them in hadn't put them in properly, hadn't been trained, and essentially when they drilled the hole, they just pushed the sleeve in Whereas when you drill a hole for a ring bolt, you should blow the hole out to get rid of all the dust so that the ring bolt won't pull out easily. So those are teasing out some of the underlying clauses. But here we are, we're talking about a really simple error of not putting the ring bolt in effectively. If they'd put 30% in and put them ineffectively, that wind may not have blown that sheet scaffold off. One doesn't know. Okay, and again, on to the third case study, simple case study. I'm sorry about the fuzzy photograph, but here we have a lorry-mounted crane which was going to be used to lift a steel platform which had been fabricated for some access stairway on, I think it was actually on a refinery. That's by the by. But this irregular shaped steel platform is probably 3 meters square, but you can see that it's shaped like an inverted letter U or a letter N. There's no steel here, but it is all around there. So about 3 meters by 3 meters. And the aim was to use this crane to lift that steel platform onto a lorry for transporting to the refinery. So it only had to lift that platform about a meter onto a flatbed lorry that was in this vicinity here. The person that was tasked with the job of putting the lifting eyes and strap onto the hook, known as the banksman or the rigger, he was killed when that platform lifting straps fell off the hook. He was stood nearby, almost underneath the platform. So it killed him. And the reason being that, again, so it's rather a close-up and therefore it gets a bit grainy. They used these soft straps on that platform to lift it and put it into a hook like this. This isn't a hook because that's a retaining device called a mouse or a clip. There was none on the crane that they used. So what that platform looked like, or could have looked like, was here. They didn't use these steel hawsers or wire ropes. They used those lifting straps. And here's a diagram with the clip missing. And I know it's more difficult for you not attending, not being in my presence or not being in an audience where I can speak to you and ask you to raise your hands. But if you're sharp-eyed, you'll see two different configurations here. And I would ask the audience generally, what difference will this make? The person who was killed was not the banksman or rigger who put this platform on the crane to bring it to the lorry. Another team had done that. And when they'd done so, they'd rigged their hook and the straps like that. And if you see, because that's the heavy side, it holds and retains in the hook. The team that then tried to put the platform on the lorry put the hook another way around, the other way around, and what happens now, the heavy side will create an upward momentum or turning motion on that, and that rope then came out of the hook and it fell to the ground and killed the person who was here. So if it's ever in life a 50-50 chance of being killed, that was it. That was a safer way. That was the one that killed him, and there was just a 50-50 chance as to which way they put the hook into the ropes. So the point I want to make about this is the final piece of the jigsaw was quite simple. It was a 50-50 chance. But there are a lot of pieces of the jigsaw, a lot of layers of safety that should have been in place before it got to that point. And here again, I've got to emphasize to you the importance of collecting the evidence at the time. When I attended the site for this fatal accident, the platform and hook were not attached. It was only by replicating the lift that myself and the engineer was able to work out that it wouldn't fall off the hook that way, but it would that way. So we had to make an assumption, but we were only able to do that because of the evidence that we'd collected. And then we created the evidence by video to show how it happened. So the importance always here is collect the facts. That's what the crane hook should have looked like, with a retaining pin, retaining mouse, a clip, and that's what should have been used. But these are now the control measures. The hook will go in there, it doesn't get overcrowded, and you've got proper hooks to go into that beam. So what were the immediate and root causes? What happened, how and why? And I think I've explained that to you. And the immediate causes are the crane hook caused the platform to fall because it wasn't sufficiently designed or maintained. The load was unbalanced. It was a heavy load. If it had been a light load, it may not have killed him. He was underneath, not using a tag line, which is a piece of rope or wire or something so you can manipulate that load remotely. It was a wrong lifting tackle. You've seen the sort of lifting chains that I just demonstrated there, and so on and so forth. The immediate causes, you could say, are the technical causes. The root causes, those are the organizational and systematic failings of the management and management system, would have been there was no recognized procedure, no risk assessment. The designers of the platform had not put any lifting points on that platform. If they'd put some eyes, welded some eyes to each corner, they could have lifted it safely. As it was, they had to use those soft straps to wrap around the corners to lift. Poor crane hook maintenance. So this is a failure of a maintenance procedures. The crane operator wasn't trained. Now, if the operator had been trained, would he have noticed whether the hook was going in the right way or the wrong way? Probably not. But he should have seen that there was no clip on the hook. How often had the dead person, DP, dead person, done that sort of work without using a tag line and so on? And it all happens because there's a poor safety culture. Management and middle management and supervisors were not doing the job, and they create some weaknesses in the control systems all the way down the line. So in that particular case study, these are typical control measures that you need to put in place. Operator training, not only for the crane driver, but for the banksman, for the rigger, for the supervisor, and probably for management as well, because there was no evidence that management had undertaken any checks or inspections. They just weren't committed. And providing lifting eyes. So all the people in the team and in the organisation had a part to play in that accident, although we're saying it was the simple thing that caused that fatal accident. Certainly, management accountability and visibility, quite often where I found after an accident, management will have a good story to tell. They will say that they're committed, but can't provide any evidence of their commitment. So just another couple of little points of the lessons I've learned through investigating accidents is you just gather information, you take down facts, you make measurements, you photograph things, you do things. Sometimes you don't know why you're doing them other than the fact that they are there, so I'll photograph them. And this particular one, there was quite recently a man killed using a tractor to break stumps of trees already felled. These are the felled trees. And as the person was using the stump grinding machine, a tragic accident happened to him, and I won't say anything more than that because it was quite recent. There will come a time when somebody will ask, well, why did that accident occur? And it would be me as an expert who would say they were using the wrong piece of equipment to break up those stumps. I would know that now because I took that photograph there, and then I counted the rings on those tree stumps. And if you see, there are 20 rings or thereabouts. So that tree was 20 years old, and the piece of equipment that that person was using will probably never be appropriate for grinding stumps that thick. So again, photograph and look at various scenarios in association with the accident investigation. Here is an accident associated with visibility. Unfortunately, something was cool when this lorry moved forward, when the wagon moved forward. And is the visibility good? Oh, maybe, but I shifted my position from where I was sitting in the cab to where the driver would have been sitting in the driver's eye line. And that's what you see. There are still 4 people there, but it's so difficult to see 4 people. So without that photograph, I think the organization would say, well, we've done a pretty good job in visibility. We've provided all these mirrors, but the mirrors and the vehicle itself actually mask and obscure some of the eye line. So again, photographs are going to be a lifesaver for some of you, particularly when you have to argue with the management about what happened and why it happened. So coming to some points about when are you going to decide to investigate and at what level do you want to choose for investigation. This is the investigation level down here, minimal through to high level investigation. And if you apply that to this table here, you'll see that's a minor investigation, low level investigation, a serious investigation, of a major high level investigation. You can apply this to your circumstances, but you've got to bear in mind here that likelihood of a recurrence is not in relation to the accident as a whole. You should apply it to the analysis that you've undertaken. So, for instance, if I applied this to the analysis of that platform fatal accident, I would be looking at the likelihood of recurrence of a banksman not using a tagline. And if the person had not used that tagline before, it's likely that they're going to have a recurrence And if it's certain that they're going to have a recurrence of not using that tagline, and the hook and load falls off the crane, you're going to get a fatal accident. So you need, in actual fact, quite a high level investigation for what seems like a fairly minor failing. So just have a think about that and bear that in mind. You can apply it to the whole circumstances of the accident, but use it on the breakdown of your analysis, and then think about what the consequences of what action you're going to take. This is a graphic taken from the accident investigation guidance that I mentioned earlier on. The link is at the end of this webinar. And here is a methodology of breaking down the actions and elements into an analytical pathway. So we've got somebody falls off a ladder. It falls off because they're on the ladder, because they needed access to the roof. The fall is due to gravity. And the plaintiff falls off because the ladder slips, because the ladder's not tied. And this is where you keep applying your why. Why wasn't the ladder tied? Why did they have access to the roof? Not much you can do about gravity, and so on and so forth. So you could keep applying the 5 whys and keep going down further and further until you've actually bottomed out. You could ask no further whys, and you note down all the answers you've got to the whys, the question and the answer. And then you'll apply some analysis to this. These human behavior failings, human factors, human error, there are various titles for this, will give you a breakdown as to why those human failings occur. And it could be through generally one of 3 areas: skill-based errors, mistakes, or violations. And the skill-based errors are that they know generally what they need to do, but make a mistake. So if you're driving a car and you put the car in forward when you're meant to put it in reverse, that would be a slip. If when you're driving your car, you answer your phone and you can't, and then you try to go back to driving the car and you can't remember where you are, or you put the car in the wrong gear again, that could be a lapse because you're distracted. A mistake is generally because you've not been trained properly, or that the rules, the procedures are wrong. Then you've got violations where people deliberately break the rules, normally because that might be the accepted ways of doing things around there, or you may violate because you're trying to prevent a disastrous consequence. This information again is on a well-known publication, HSG 48, which again you'll find on the HSE's website. But as in all these things, your own country's regulators generally have an approach on accident investigation and behavioural issues, which may be different. So I mentioned safety differently. This is a fairly modern title to try, and there's a campaign associated with it, which has the intention of trying to refocus safety professionals and organisations on the way in which they approach safety management. And because of this plateauing effect, then that safe workplaces can only operate, they can only really be successful if you have safe workers. And how do you make workers safe? Well, quite often it's been on a rule-based and discipline-based approach. Safety differently, it has got a different approach here. I think we had on the previous slide something to do with human factors and behavior. You can only go so far in trying to prevent those human failings through regulation, discipline, procedures, risk assessments, and training. It will only take you so far. So with safety differently, they're now focusing on individual approach, the workers' approach and attitude to health and safety. Now that's all very well to try to make a safe worker by trying to change their behavior and their approach and their actions and attitude. But in this movement towards increased technology, where workers are becoming less skilled, or the majority of workers are being less skilled, robots are taking over, jobs are being simplified and de-skilled, and more complexity, it's very difficult to think about how you could motivate an even lower paid worker with less training and less commitment to their job to try and behave even more safely. That's a result of moving towards the way technology is moving with robotics and with digital technology. So there'll be new roles and responsibilities. There's a move, isn't there, to more highly skilled but fewer people, and fewer of those skilled people lower down the hierarchy of work. I mentioned that there's an issue about human factors and the conventional risk approach falling behind. Rule-based thinking just is not going to be the answer. And this move from bureaucratic accountability to individual and ethical responsibility. To some safety professionals, we're part of a problem. And that's why health and safety professionals quite often get a bad press, certainly in the UK and in other countries. And from leaders of organisations, we're seen to be a problem, not a solution. And the solution lies in having a better attitude from workers. And this is all very well, but whether we can make that happen across the board, it is going to be a big challenge. So when we're doing our audits of organisation, the checklist, we normally end up finding fault and trying the best as we can to provide solutions to people, to persuade them, and through good communication, interpersonal skills, and approaching top management to get their commitment. Quite often, we're still seen to be the ones who are finding the fault. But we need to be able to turn that around and demonstrate the business case and the ethical and the moral case for safety improvement. But you need to engage with top management to do that. So it's a significant hurdle. However, perhaps from this presentation, you've picked up the reason why the minor incidents and the minor failings that we're finding, and it was still in this one, in these case studies, can lead to fatal accidents and tremendously costly losses to an organization. And that's why when you do sometimes focus on the minor, don't let them say it's the trivial, because you look at the consequences of what may happen if there are failings of other parts of the control system, supervision, maintenance, and so on and so forth. So a changing role for safety practitioners, possibly. but we're all on a different level of maturity as safety practitioners and attendees at this webinar. And where you are on that pathway is something that you will only know. And I think my message to you is certainly deal with the facts and don't be diverted from getting those facts, and then use them with good communication, interpersonal skills to turn them into actionable and achievable plans. Okay, I've come to the end of what I want to say. Ardian may have some questions for me that he's gleaned. I'm happy to answer them, but if we can't deal with them now, either through getting it being short of time, or they're too complex for me, or I need time to respond, we will do that for you. So I've taken some of those screenshots and information from that guide. Click on the link and it'll take you to it. The Buncefield Fire information is on Wiki. Investigation techniques differ in different countries, and look at the diversity to work out what works for you. There's a US technique, that's the EU technique, no doubt. I looked in other countries, each country generally has a different approach or some different takes on the same thing. I'm Chris J. Ward. I've got a website and a consultancy which concentrates on the 45001, which is a new safety management standard which you may have come across. Interestingly, this standard actually mentions and mentions human factors and behavior, and it classifies human behavior as a risk, which is an interesting and far-sighted approach. So if you need further on ISO 45001, I've got something to say on the matter and the link to my website. Nevertheless, PCB have got something to say about 45001, which, Ardian, is a good opportunity to hand over to you, I think.
Yes, thank you, Chris, for this very great presentation, and also thank you for providing us with the case studies.
Ardian, I've lost sound. I'll get back in a minute if you're speaking.
So once again, thank you, Chris, for this very great presentation. I want to inform you that PCB provides training and certification services for ISO 45001 Introduction, Foundation, Lead Implementer, Lead Auditor, and the Transition course. A PCB certificate in these courses will exemplify your dedication in implementing and managing ISO 45001 processes and frameworks, and most importantly, you will be recognized worldwide. Now, we'll go ahead and take some time to answer some of the questions from the attendees regarding today's session. So the first question is related to the human error. So once again, what should be done if the accident investigation reveals human error?
Okay, so can I take time to go back to human error? Have I run past this slide, Ardian? There we are, sorry. So it depends which part of this block, which block of that error is. This is where you've gathered the facts and you understand that there is a human failing. You then need to break that down by analysis to understand whether it's skill-based, in which case you'd then have to look at why was there a slip, was the person distracted, or why was there a lapse? Were they tired? Was there another reason why they weren't concentrating on the work? So these are where you have skilled people. This is where there are unskilled people. So do you need to look at their knowledge and training and competence, or did they follow the rules but because the rule was wrong, it turns out to be a mistake. So look at the rules. And if you look at violations, so they deliberately broke the rules. Was it a accepted practice in that organization? Was it a sort of routine violation? Did everyone break that rule? Was it done day in, day out, and the supervisor and management not dealt with it? Was it situational? In other words, were the how should we say, the organizational factors around that violation so creating so much pressure to them? Perhaps the speed of work. They had too many things to do on a production line, and therefore they had to take a shortcut. Was that because the pressure of work was too great? That's situational. Or was it exceptional? Did they violate the rule just to save their life, for instance? So where you have human error, you need to break it down and then do further analysis and keep on moving over to the right and think why, until you've got to the stage where you've broken it down into something that you can then turn into an action. And it may be training, it may be supervision. As likely as not, you'll need to have better leaders. And this is one of the reasons why, because this is so difficult to try and change people's behavior, unless you've got time, effort, resources, and committed leaders, why this safety differently approach is starting to gain some traction. But it's going to be such a big task to cut out all these errors that you need to provide more and more resources to make a safer worker, because there's only so many things you can do in a safe workplace. I hope that helps. This is taken from HSG 48. So if the questioner wants to look into more detail in that, there's a very good explanations in HSG 48. There's also on HSC's website something called performance influencing factors. If you Google that on HSC website, you'll have a good checklist of how you can shape people's behavior to avoid errors. I hope that helps, Ardian.
Yeah, thank you, Chris. Now another question related to human errors is, can they be completely avoided in a system?
As long as there are human beings, Ardian and questioner, it's like the poor. The poor will always be with us, and if you've got human beings, there will always be errors. The issue about the error is, well, we all make errors, but does it have a tragic consequence? And if you can create a place, and this is a blend of a safe workplace and a safe worker, if you make the workplace safer and safer with technical measures and so on, the error may not end up in tragic consequences. I think this, sometimes there may be an error in thought, but not in action. So you think, oh, I've thought I'm going to do something, and then find out it's the wrong thing to do, but you've not actually instigated your behavior or actioned your behavior. Well, the error will not end up in a consequence that's tragic. However, with this move towards technology, of course, increasing digitalization, individual human error can be manifestly levered up into have a worldwide consequence, can't it? Because with telemetry and so on and so forth, one person may be controlling through a digital computer system a massive organization. So that one error can now have more tragic consequences than ever our forefathers thought about. So the answer is there will always be errors, Adrian. Adrian, but it's trying to minimize the consequences with the layers and layers of protection and protective systems. Okay.
Yeah, okay. Thank you, Chris. I think with that question, we'll conclude the presentation because of the time limitation. I want to thank you once again for delivering this great session and also thank everyone for attending today's webinar. I would like to let you know that this webinar will be recorded and posted on our website as well as on our YouTube channel together with the slides of the presentation. For more information, you can visit our website www.pecb.com. Thank you all and have a great day.